If you look at our topology diagram, we choose an extended star topology. So in the middle, we have a HQ router, and from there, we connect all the four networks together. The HQ network, northern branch, southern branch, and the central data center. And each network has its own switch and access point to connect all the wired and wireless devices together. Now, I will explain why we choose the extended star topology for our project. The first one is centralized management. All networks connected together through one central HQ router in the middle, and this makes it easier for us to monitor, manage, and control the whole network from a central point. The second one is scalability. If the company expands in the future, we can easily add more branches or devices without changing the whole network structure. And lastly is fault isolation. If one branch or switch has a problem, the rest of the network will still function normally, and this makes troubleshooting and maintenance more efficient. So overall, this topology is reliable, simple to manage, and suitable for a growing company like Innotech.
First, we will start with headquarters network. The subnet address is 192.168.200/24. The device we need to use is 2 network printers, 5 desktop PCs, and 5 wireless laptops. The requirement is first, printers and PCs must be connected via wired internet to the HQ switch. And second, laptops must connect wirelessly via an access point. Okay, first, for HQ router, we will be connected to HQ switch via port fast Ethernet 00. And HQ switch will be used 9 port. First, we will ping with the branch. We will use ping PC1 to PC3. Ping 192.168.2012. All packets successful sent. Next, we will ping pring1, ping 192.168.2020. And lastly, we will ping laptop, ping 192.168.2054. And all packets are successful sent. Next, we will ping PC to other branch. First, we will ping PC4 to South PC2. And next, we will ping HQ laptop 4 to North laptop 1. And all packets are successfully sent. Next, we will send email to other branch. We will send to North branch using email north1innotech.com, and the subject is payroll. Then we will check the email received.
As for the northern network, the subnet address given is 192.168.30.0/24, and the devices needed are a printer, 2 desktop PCs, and 2 wireless laptops. And the requirements are all wired devices connect through the northern branch switch, and laptops access the network via a wireless access point. As you can see from the picture beside, all the requirements are achieved. From the pinging test between devices in the northern branch, you can see that those pinging tests are successful between the PC and another PC, and PC and the laptop, and then between the laptop and the printer inside the northern branch. The testing pinging between different branches. So you can see that the northern laptop can ping successfully to the southern laptop, and the another northern laptop can successfully ping the HQ printer. These are the testing for DNS server and HTTPS server. Lastly, the FTP server. Yeah, as you can see from the picture, the testing is successful because you can see that I can log in and access the FTP server.
So now I'm going to continue with the southern network. So this LAN uses the 192.168.40.0/24 subnet and includes 2 PCs, 1 printer, and 3 wireless laptops connected through an access point. All IP addresses for the laptops are automatically assigned via the HTTP. From the picture, we can see the topology of this local area network. We can see the southern switch and the access point connects to the switch to serve wireless laptops. Here you can see that interface Gigabyte 9/0 is configured with IP 192.168.40.1, and the HTTP is set up to assign IPs from .11 onward. Moving on to the IP configuration for each devices, we can see the configuration for both the access point and the laptop. So based on this picture, we can see that the laptop is connected to the Southern Wi-Fi SSID and successfully receives an IP via the HTTP, confirming the wireless and HTTP setup is working. For the wired devices in the southern branch, I have assigned static IP addresses to ensure consistent and reliable addressing. PC1 is manually configured with IP 192.168.40.11, PC2 uses 192.168.40.12, and the printer is assigned 192.168.40.13. All devices share the same subnet mask, and the default gateway is set to 192.168.40.1, which matches the router's interface. Next, I will test connectivity by pinging the default gateway 192.168.40.1 from one of the PCs. This is to confirm that the device is able to communicate with the router, which is essential for accessing other networks. After typing the ping commands to the default gateway, based on the picture, we can see there are replies which indicate successful communication. I will now try pinging the HQ router interface at 192.168.20.1. This tests whether inter-branch routing is working between the southern branch and HQ. The successful replies confirm that routing between branches has been configured correctly. In this part, this is how a wireless laptop in the southern branch sends an email to a device in the northern branch using the email server hosted in the data center. This demonstrates how devices from different networks can communicate and benefit from centralized services like email. I have configured the email client on Southern Laptop 1 to use the data center's mail server at 192.168.50.13, which handles both incoming and outgoing mail. Now, I will compose an email to the northern branch. In the northern branch, I have opened the email client on the northern laptop 1, which configured the same mail server and checked for incoming messages. As you can see, the message from the southern laptop has arrived. This confirms that wireless communication, inter-branch routing, and centralized email services from the data center are working as expected.
For this project, I am responsible for setting up the central data center network, which uses the subnet 192.168.50.0/24, and I configured 5 servers using static IPs, the DNS server for name resolution, the web server HTTP for public website, the secure web server HTTPS for secure login portal, the FTP server for file sharing, and the email server for staff email communication. And all the servers are connected to switch network, and the DNS is set to 192.168.50.14 to support the domain names like www.inotech.com. And here's what I configure for each of the servers. So now I will explain how I test the data center servers to make sure they function properly in our network. So first, I open any PC or laptop in our network and go to the web browser and type www.inotech.com. The homepage appears successfully, and this shows that our HTTP server is running, and also proof that the DNS server is working because the domain name was successfully resolved into the correct IP address. And I also edit the HTML file on the web server, also the secure web server, to include a custom page for representing our company's public website and secure login portal. To test the FTP server, I use the command prompt on any PC or laptop and connect it to the ftp.inotech.com. I log in using FTP credentials, and as you can see in the screenshot, it successfully logged in and displayed a list of files from the server. This confirms that the FTP service is active, reachable from the network, and functioning as expected. But just a note, in Cisco Packet Tracer, the FTP is only simulation, so the actual file transfers like upload or download will not happen. But the login and file listing prove that the configuration works well.
So, in conclusion, this laboratory assignment successfully demonstrated the implementation of a complete local area network LAN infrastructure for a growing company by using Cisco Packet Tracer. The network is divided by 4 mains, which is headquarters, northern branch, southern branch, and the central data center, each configured with appropriate IP addressing schemes and devices. Key networking principles such as subnetting, device configuration, and wireless connectivity were applied effectively. The setup met all specified requirements, including wired and wireless connections, printer integration, and server configuration for web and FTP services. The use of a central HQ router ensured seamless internet interconnectivity among all subnets. This project has boosted our practical understanding of network planning, topology designing, and troubleshooting. It also reinforced the importance of organizing network documentation and systematic implementation for scalability and maintenance. Overall, the activity provided us a valuable hands-on experience in building a real-world LAN environment.